Unit 3, Topic 2, Video 24, Motion in a Straight Line. I'm going to go through example 21, which is about a cricket ball projected vertically up from the ground with an initial speed of 15 metres per second. The origin is the point of projection, and the acceleration is negative j. The j is obviously the vertical direction. So that initial speed, so VO at time 0 is actually 15j. So that's initial. Our initial, O is our point of projection. So our initial position is 0. That will help us as we go, because in this question, we've been given the acceleration first, and we need to work backwards or integrate to find the speed, the position vector, the max height, and the time taken for the ball to come back down to the ground. So if we've got the acceleration and we need to find the velocity as our first one, velocity, I often call it V, the textbook often calls it R dot. That's our first thing we need to find. So we need to integrate. Negative GJ will become negative GTJ plus C. Remember, integrating, we always need to account for that constant. But we can find C. We're going to find C by using the fact that we know that the initial velocity was 15j. So we know that R dot 0, which is negative G0j plus C, has to equal 15j. This is 0, so therefore C equals 15j. So we can now write our velocity, V if you prefer, as negative GTJ plus 15j. Put it all together in brackets, 15 take GTJ. You could leave it as negative GT plus 15, but it seems a bit nicer putting it that way. But either would be fine. Next, we're asked to find the position vector. So we want to find RT. So we've got to integrate again. So RT is going to equal, now we're integrating this. So that's going to become 15t minus gt squared on 2j plus c. So we're going up here, so we've got the 15 become 15t, the take gt became take gt squared on 2, that's all still j, plus c. Then we need to find c, but we're told that the initial position was 0. So R0, 15 times 0, minus g times 0 squared onto j plus c has to equal 0. So in this case, c equals 0. So RT equals 15t minus gt squared on 2j. Can't really factorise that much. You could take the t outside and make it 15 take gt on 2j. About the best you can do. So we've found velocity and we've found position vector. We were asked to find the max height. Now, if you throw a ball up directly vertically, when it's the max height is when the velocity equals 0. So we need to look at our velocity. So our velocity was, go back down here, our velocity was 15 take GTJ. So we're basically going, what's 15 take GT equals 0? That's gt equals 15, t equals 15 on g. So the max height occurs when the time is 15 over g. You could get a decimal for that if you did it on your calculator. I'm just going to leave it as over g because I just don't have my calculator with me at the moment. But that hasn't answered my question. I know the time when it occurs max height, but I haven't got what that max height is. So I need to go back now and look at position vector r at time 15 on g. Now, just go back up here. We'll use the top one. So we'll have 15 by 15 on g minus g 15 on g squared over 2j. Of course, a calculator is going to give you a nice simple answer. 225 on g minus 225 on 2 on g as well. Blech. I'm just going to check. Oh. If you do that in your calculator, it's approximately 11.48 meters. Okay? Calculators are handy. The other thing was time to get back to the ground. Now, if you think if you've thrown a ball up and it's taken 15 on g seconds to reach the maximum, it's actually going to be the same coming down. So to hit the ground, it will be at time 30 on g because it had to go up and then back seconds. And that was time. Now, I believe that's approximately 3.06 seconds. Thank you.